A ladder that is 8 meters long is leaning against a non-vertical wall that slopes away from the ladder. The foot of the ladder is 3.5 meters from the base of the wall, and the distance from the top of the ladder down the wall to the ground is 5.75 meters. To the nearest tenth of a degree, work out the acute angle at which the ladder is inclined to the horizontal. So I'm reading that as the angle made between the horizontal ground and the base of the ladder. Right, so we're going to have to draw a picture. I do like this problem because you'll see the classic ladder wall problem in almost every maths book ever written. But I've never seen one with a non-vertical wall. So obviously the point of this is so that we can't use SOHCAHTOA. So it is interesting. So we can have the ground. We can have our non-vertical wall. Then we need to try and get some scaling. So it says the distance from the top of the ladder down the wall to the ground is 5.75 meters. And the foot of the ladder is 3.5 meters from the base of the wall. So if we said maybe this is, that distance there can be your 3.5 meters. That's from the foot of the ladder to the base of the wall. Then 5.75 is going to be sort of that. Plus not much, difference to half of it again. So maybe it can probably go all the way up to there. So that whole side length can be 5.75 meters. And then we can finish this off. This is the actual ladder. So just so we're clear, this is wall and this is the ground. And this is the ladder. Okay, and it tells us how long the ladder is. It says it's 8 meters long. So that distance there is 8 meters. Okay, so and the question says to the nearest tenth of a degree, work at the acute angle at which the ladder is inclined to the horizontal. So I'm going to calculate this angle. Okay, so this is, look at the triangle, no right angles. This is side, side, side. As in, you have 3 sides, you need to find an angle. This is cosine rule. So what you want to do when you use cosine rule, whatever you want, personally I'm going to call it A. Your formula book, the subject is C, so you might want to call it C, or you might want to just learn the formula in this way. If you've done a few of these problems, you really shouldn't need to look at the formula book to check the cosine rule. Okay, so we're going to label this angle, we want A. Little a, as in side A is opposite the angle A, it's there. B and C are just the other 2 sides, doesn't matter which way around. So then the cosine rule, as I remember it, is A squared equals B squared plus C squared minus 2BC cos A, which means that 2BC cos A equals B squared plus C squared minus A squared, which means that cos A equals B squared plus C squared minus A squared over 2BC. So now we can substitute values in. So cos A equals B squared, 8 squared, plus C squared, 3.5 squared, minus A squared minus 5.75 squared all over 2BC. So 2 times B, 8 times C, 3.5. Go to your calculator. 8 squared plus 3.5 squared minus 5.75 squared all over 2BC, so 2 times 8 times 3.5. So that gives us an answer for cos A of 0.7712. So A must be the inverse cos of that. A must be the inverse cos of that. So I could look saying cos minus 1. Do remember this is arc cos. So A equals inverse cos of 0.7712 dot dot dot. Go to your calculator, shift cos ANS equals 39.5377. And that is our answer. So the ladder makes an angle. Actually, let's just see exactly the wording of this. Ladder is inclined at 39.5 degrees to the horizontal. .5 degrees to the horizontal.